Download this code from codegive.com, link in the description below. Amazon Kinesis Data Streams, a deep dive with code examples. This tutorial provides a comprehensive overview of Amazon Kinesis Data Streams, covering its architecture, core concepts, and practical implementation with code examples in Python. We'll explore how to ingest, store, and process real-time data using Kinesis data streams, enabling you to build scalable and resilient data streaming applications. 1. Introduction to Kinesis data streams. Amazon Kinesis Data Streams is a fully managed, scalable, and durable real-time data streaming service. It enables you to continuously capture and process large volumes of data from various sources, such as website clickstreams, application logs, social media feeds, IoT device telemetry, and more. Key advantages ** real-time data ingestion ** efficiently captures data at high velocity and volume. Scalability * automatically scales to accommodate varying data rates. Durability * replicates data across multiple availability zones for high availability and fault tolerance. Cost-effective * pay-as-you-go pricing based on the resources you consume. Integration * seamless integration with other AWS services, such as Lambda, Firehose, S3, Redshift, and more. 2. Kinesis Data Streams Architecture. The architecture of Kinesis Data Streams consists of the following key components. Producers * applications or devices that generate and send data to the Kinesis data stream. Kinesis data stream * a logically grouped sequence of data records that provides ordered data delivery. Shards * the fundamental unit of parallelism in a Kinesis data stream. Each shard acts as an independent pipe for ingesting and processing data. The number of shards determines the overall read/write capacity of the stream. Consumers * applications that retrieve and process data from the Kinesis data stream. They can be simple applications consuming data directly from the stream or more complex processing pipelines built with services like Lambda or Kinesis Data Analytics. Detailed breakdown *. 1. Producers *. Producers send data records to the stream. Each data record consists of data * the actual data payload, example JSON, CSV, plain text. Partition key * a string used to determine which shard the data record is assigned to. Records with the same partition key are guaranteed to be placed in the same shard. This ensures order within a partition key group. Optional, explicit hash key, allows fine-grained control over shard placement. If not specified, Kinesis uses the partition key to generate a hash key. 2. Kinesis data stream *. A logically named collection of shards. Data records are persistently stored for a configurable period, default 24 hours, maximum 7 days. Provides ordering of data records within each shard. 3. Shards *. A unit of throughput capacity within a stream. Each shard can support write capacity 1 MB/second or 1000 records/second. Read capacity 2 MB/second. The number of shards needed is determined by the expected data ingestion and processing rates. 4. Consumers * retrieve data from the Kinesis data stream and process it. Different consumer types exist. Kinesis Client Library, KCL, a Java-based library that simplifies building robust and scalable consumers. It handles shard discovery, checkpointing, and load balancing across multiple consumer instances. Kinesis Data Streams API, direct integration. Consumers can directly interact with the Kinesis Data Streams API to retrieve data. This approach requires more manual management of shards and checkpointing. Kinesis Data Firehose a service that automatically delivers data from a Kinesis data stream to destinations like S3, Redshift, or Elasticsearch. AWS Lambda serverless compute service that can be triggered by new data arriving in the Kinesis data stream, enabling real-time processing without managing servers. Kinesis Data Analytics allows you to run SQL queries on streaming data from Kinesis data streams in real time for complex analytics. 3. Setting up your AWS environment. Before you start, you'll need 1 AWS account. If you don't have one, create an AWS account. 2 AWS CLI *, install and configure the AWS command line interface, CLI, with your AWS credentials. 4. Creating a Kinesis data stream. You can create a Kinesis data stream using the AWS Management Console, AWS CLI, or SDK. Here's how to do it using the AWS CLI. * stream name, the name of your Kinesis data stream. * shard count, the number of shards you want to provision. Start with a small number and adjust based on your needs. It takes a few minutes for the stream to be created. You can check its status using. Look for the stream status field in the output. It should be active before you can start sending data. 5. Producer example, Python. This example demonstrates how to send data to a Kinesis data stream using the Botto3 library, AWS SDK for Python. Explanation * 1. Import libraries * imports necessary libraries, Botto3, AWS SDK, JSON, for serializing data, time, for timestamps, and random, for data generation. 2. Configuration * defines the stream _name, your Kinesis data stream name, and region _name, your AWS region. Replace these with your actual values. 3. Kinesis client * creates a Botto3 Kinesis client to interact with the Kinesis data streams API. 4. Generate _sensor _data, * simulates sensor data generation. You would replace this with your actual data source. It creates a dictionary with sensor _ID, temperature, humidity, and timestamp. 5. Send _data to Kinesis, *. Takes data as input. * serializes the data to JSON using JSON.dumps. Kinesis data streams expects data as bytes. * calls Kinesis _client.put _record, to send the data to the Kinesis data stream. * stream name, specifies the name of the Kinesis data stream. * data, the data to send, as bytes. * partition key, crucially, sets the partition key. In this example, we use the sensor _ID as the partition key. This means that all data from the same sensor will be routed to the same shard, guaranteeing order within that sensor's data. * prints a success message with the shard ID if the data is successfully sent. * handles potential exceptions during the sending process. 6. Main loop * continuously generates data, sends it to Kinesis, and waits for 1 second before repeating. How to run *. 1. Install Botto3 * pip install Botto3. 2. Replace placeholders * update stream _name and region _name with your values. 3. Execute * python your _script _name.py. Important considerations for producers *. Error handling. Implement robust error handling and retry mechanisms to ensure data delivery even in the face of temporary network issues or Kinesis service interruptions. Throttling. Kinesis data streams can throttle producers if they exceed the shard write capacity. Monitor the put record. Throttled records metric using CloudWatch and implement exponential backoff and jitter to retry requests gracefully. Partition key choice. The choice of partition key is critical. It determines how data is distributed across shards. Choose a partition key that evenly distributes data across shards to avoid hot shards, overloaded shards. If you want guaranteed order within a specific context, like a sensor ID, that context should be part of the partition key. Batching. For higher throughput, consider using put_records, plural, API to send multiple records in a single request. This reduces the overhead of individual API calls. Data serialization. Choose an efficient data serialization format, example JSON, protocol buffers, Avro, that minimizes the size of the data records. 6. Consumer example, Python using KCL emulation. Directly consuming from Kinesis using the raw API is complex. However, for illustrative purposes, we can emulate a KCL-like consumer. A real KCL consumer is typically written in Java. This Python example demonstrates how you could iterate through shards manually. This is not a replacement for KCL, but a simplified illustration. Explanation. 1. Dependencies and client * same as the producer example. 2. Get _shard _iterator, shard _ID, iterator _type, *. Takes a shard _ID and an iterator _type as input. Calls Kinesis _client.get _shard _iterator, to get an iterator for the specified shard. Shard iterator type, determines where the iterator starts reading from. Common options. Latest, starts reading from the most recently added records. Trim _horizon, starts reading from the oldest available record in the shard, the beginning. *at _sequence _number, starts reading from a specific sequence number. After _sequence _number, starts reading after a specific sequence number. Returns the shard iterator string. 3. Process _shard, shard _ID, *. Takes a shard _ID as input. Gets a shard iterator using get _shard _iterator. Enters an infinite loop that continuously retrieves and processes records from the shard. Kinesis _client.get _records, shard iterator, limit, retrieves up to limit records from the shard, starting from the current iterator position. Iterates through the retrieved records. Deserializes the JSON data using JSON.loads. Prints the processed data. Replace this with your actual processing logic. Crucially, updates the shard _iterator with the next shard iterator returned by get _records. After each successful read, this moves the iterator to the next position in the shard. Handles potential exceptions during retrieval and processing. If an error occurs, it waits for a short time, and then gets a new shard iterator to continue processing. If no records are found, the shard is empty, it sleeps for a few seconds and then tries again. For main, *. Gets the description of the Kinesis data stream using Kinesis _client.describe _stream. Extracts the list of shards from the stream description. Iterates through the shards and calls process _shard, for each shard. How to run asterisk. 1. Install Boto 3 asterisk pip install Boto 3. 2. Replace placeholders asterisk update stream underscore name and region underscore name with your values. 3. Execute asterisk python your underscore consumer underscore script.py. Important considerations for consumers, direct API approach. Asterisk checkpointing asterisk you must implement a mechanism to track the last process sequence number, or record, for each shard. This is crucial for recovering from failures. Without checkpointing, the consumer will reprocess data from the beginning of the shard after a restart, leading to duplicated processing. KCL automates checkpointing. For direct API consumers, you need to persist the sequence number, example in DynamoDB, after processing a batch of records. Asterisk shard splitting / merging asterisk Kinesis data stream supports splitting and merging shards to adjust capacity. Your consumer needs to be able to handle these events by dynamically discovering new shards and stopping processing of old shards. KCL handles this automatically. Direct API consumers need to poll the describe_stream API to detect shard changes. Asterisk throttling asterisk implement retry logic with exponential backoff to handle potential throttling by the Kinesis data streams service. Asterisk ordering asterisk data records are ordered within each shard. If you need global ordering across the entire stream, you need to ensure that all records are sent to a single shard, which defeats the purpose of sharding for scalability. 7. Using Kinesis Client Library, KCL. The KCL simplifies the development of Kinesis data streams consumers. It handles shard discovery, load balancing, checkpointing, and other complex tasks. KCL is Java-based. Here's a general outline. 1. Create a KCL application * follow the KCL documentation to create a Java application that implements the iRecord processor interface. 2. Implement iRecord processor *. Initialization input, called when the record processor starts. You typically get the shard ID here. Process records input, called for each batch of records. Implement your processing logic here. Checkpoint the last processed record using process records input.get checkpointer.checkpoint. Shutdown input, called when the record processor is shutting down. Checkpoint the last processed record before exiting. 3. Configure and run * configure the KCL application with your Kinesis data stream name, AWS credentials, and other settings. Run the application. 4. Scaling * you can run multiple instances of the KCL application. The KCL will automatically load balanced shards across the instances. Example, illustrative Java snippet, not complete. Advantages of KCL * simplified development * handles complex tasks like shard discovery, load balancing, and checkpointing. Scalability * easily scale your consumer by adding more instances. Fault tolerance * automatically recovers from failures by restarting record processors on different instances. Guaranteed processing * ensures that all records are processed exactly once, at least once, with proper checkpointing. 8. Alternative consumer options, Kinesis Data Firehose, Lambda, and Data Analytics. Kinesis Data Firehose * a fully managed service that automatically delivers data from Kinesis data streams to destinations such as S3, Redshift, Elasticsearch, and Splunk. Suitable for use cases where you need to archive data, load data into a data warehouse, or analyze data using other services. Asterisk supports data transformation using lambda functions before delivery. Asterisk AWS lambda asterisk. Asterisk a serverless compute service that can be triggered by new data arriving in a Kinesis data stream. Asterisk allows you to process data in real time without managing servers. Asterisk suitable for use cases such as data enrichment, data validation, and triggering actions based on data events. Asterisk Amazon Kinesis Data Analytics asterisk. Asterisk allows you to run SQL queries on streaming data from Kinesis data streams in real time. Asterisk enables you to perform complex analytics, such as calculating aggregates, detecting anomalies, and joining data streams. 9. Monitoring and scaling. Asterisk CloudWatch metrics asterisk Kinesis data streams provides a variety of CloudWatch metrics that you can use to monitor the performance and health of your streams, such as asterisk incoming bytes, the rate of incoming bytes. Asterisk outgoing bytes, the rate of outgoing bytes. Asterisk put record success, the number of successful put record operations. Asterisk put record throttled records, the number of put record operations that were throttled. Asterisk get records success, the number of successful get records operations. Asterisk get records throttled, the number of get records operations that were throttled. Asterisk iterator age milliseconds, indicates how far behind a consumer is in processing data from a shard. A high value indicates a slow consumer. Asterisk scaling shards asterisk you can increase or decrease the number of shards in a Kinesis data stream to adjust its capacity using the splits hard and merges hards operations. Asterisk splits hard asterisk splits a shard into two shards. Use this when a shard is becoming a hot shard, overloaded. Asterisk merges hards asterisk merges two adjacent shards into one shard. Use this when you have underutilized shards. Asterisk you can automate scaling using the Kinesis scaling utility or custom scripts. 10. Security. Asterisk IAM roles asterisk use IAM roles to control access to Kinesis data streams. Grant producers and consumers the necessary permissions to send and retrieve data. Asterisk encryption asterisk Kinesis data stream supports encryption at rest using AWS KMS and encryption in transit using HTTPS. Asterisk VPC endpoints asterisk create VPC endpoints for Kinesis data streams to access the service from within your VPC without using the public internet. 11. Best practices. Asterisk choose the right partition key asterisk distribute data evenly across shards to avoid hot shards. Asterisk monitor your streams asterisk track CloudWatch metrics to identify potential issues. Asterisk scale your shards asterisk adjust the number of shards based on your data volume and velocity. Asterisk implement error handling asterisk handle potential errors gracefully and retry requests as needed. Asterisk use the KCL asterisk simplify consumer development and ensure scalability and fault tolerance. Asterisk consider Kinesis data firehose, lambda, and data analytics asterisk leverage these services for data delivery, processing, and analytics. Asterisk secure your streams asterisk use IAM roles, encryption, and VPC endpoints to protect your data. 12. Summary. Amazon Kinesis Data Streams is a powerful service for building real-time data streaming applications. By understanding its architecture, key concepts, and best practices, you can effectively ingest, store, and process large volumes of data in real time, enabling you to build innovative and data-driven solutions. Remember to choose the right tools, KCL, firehose, lambda, etc., based on your specific use case requirements. This tutorial provides a solid foundation for working with Kinesis data streams. Remember to explore the official AWS documentation and experiment with the service to gain a deeper understanding.